So obviously we don't have this val_x word. Pixels per meter, we'll get rid of all of that for now. Okay. We just have to give it two numbers, an x and a y. Like if I say 10 and 10, it will, and I get rid of gravity, it'll move on its own. It'll start moving. Whatever those numbers mean to it. I don't know if they're pixels per second or box 2D's meters per second. I don't know if that angle is in degrees or radians. Doesn't like that. Oh, you know why? Because this is B, but I actually have my variable body that is is my way of setting box 2D stuff. There it goes. 10 and 10 apparently is kind of like that. So it's definitely not pixels per second, because that would be really slow moving, right? Take a long time to get across the screen. And it doesn't look like that was 10 degrees either, does it? So let's set it to the angle and speed we want. Does this thing let us do cosine? No. Or sine? I'm just going to write sine of 10 and see. It might not let us do sine. Oh no, it does. Okay, cool. So this is just an x and a y speed, right? So if we know the speed and the angle that we want, we got to use, where's my little pen here for anyone who's ever taken any kind of math course, like, all right, polar coordinates, let's see here. Here is the speed, right, and the angle that I want to launch it at. But it's looking for an x and a y component of that speed. It's looking for the x and the y, so I actually need to pass it this one, this vector, I guess, call it a vector. And I need to pass it in the y direction, this vector, okay? But this is the speed, let me get my black pen back. This is the speed we're gonna give it, right there, s. Okay, so if I want to pass it this will just be s times sine of theta. Convince yourself of that. And this will be s times the cos of theta. Convince yourself of that. It's by Pythagoras's, whatever you call that, you know. Trigonometry. There you go. Okay. All right, so I have my speed and my radius, so I'll just go, or I have my speed and my angle, so I'll just go speed times sine of angle. Sine doesn't autotype, but it does work. And then speed times, oh no, this should be cos, sorry. It's a little bit messed up too, because like, here's an issue we're gonna run into too. Right, in math, the x and y look like this. It's very easy to deal with, right? But we saw in SFML, I think down is up and up is down, so it looks like that. And then box 2D, I think, is like normal, right? So we're going to have some confusion as to what's up and what's down, depending on if we're thinking SFML or box 2D or even real world. So we'll be conscientious of that. But I'm going to write times the sine of angle here. And I gave it an angle of, let's see, I gave it an angle of 45, a speed of 45 and an angle of 45. So I'm looking for something that when I run this ball, 45 is going to be really fast, by the way. That's definitely not 45 degrees though. So I'm going to slow this down by dividing the speed by this special number. It's a number that's included in box 2D to convert from meters to pixels. It is called pixels per meter. Okay. Notice I also have a constant in here that changes from degrees to radians. Not all of you may know what a radian is, but it's another way to measure an angle. So if you have a circle, right? Blah. That is a terrible circle. Humans in the past have decided to break that up into 360 pieces, 360 degrees. And that's fine. 360 is a really nice number. It actually divides by like 2, 3, 4, 5, 6, 8, 9, 10, 12, 15. You get the idea. 18. That's why it was chosen probably in the past, right? 24, 30 definitely divides in there. Yeah, you get the idea. It's a great number for having lots of divisors. It's also close to the number of days in a year, 365, right? So I think probably over time we've just evolved to take a circle and divide it into 360 pieces. And it's been working really nicely for us. But if we went to another planet where they're not necessarily 365 days in a year, or they have a different number system, they won't know what the heck you're talking about if you're talking about a circle with 360 degrees, right? So the way we actually universally measure a circle's angle is we measure it as a radian, and we say that it has to do with like the distance around the circle, the circumference and the radius, but basically we say 360 degrees equals 2 pi. It's this, we talk about it as the circumference of the circle and of a radius 1. Okay, so you just assume every circle's got a radius of 1. And then if you want to go one angle around it, or 1 degree around it, you say 2 pi is 360, and you divide it by 360 if you want to figure out what 1 degree is in radians. Now pi is a number close to 3, right? So it's actually like 6.28 instead of 360. Okay. It's a much smaller number as well. And I think you can see my conversion here. I probably just did 180 divided by pi. Yeah, that's the same as 360 divided by 2 pi. Okay. So a lot of calculators and math stuff uses radians because it doesn't want to think about 360 degrees. Like if you type on C++, if you type cosine of 180, it won't do the It'll need it in radians. So I'm just going to divide this by pixels per meter. I'm going to divide this speed by pixels per meter. And this angle was given in, so that'll take care of the fact that Box 2D uses a different measurement than SFML. It uses meters and our program has apparently, it told me in the setting, or like when I downloaded it or under the FAQ, to set pixels per meter to around 32. So every 32 pixels represents a meter in our world. So that's a good ballpark figure. Okay, so if this is an angle in degrees, I need to switch it to radians. So I have it in degrees. I should divide it by, oh, this is degrees per radian. Yeah, I have it in degrees. I should divide my angle by this, and that'll give me radians on the top. So if I go to ball there and just write divided by degrees per radian, it auto types it. We won't have to do this ever again, but this conversion thing is a bit of a pain in the butt, kind of confusing. So hopefully once we just write it here, then we're good to go. And let's see if this thing moves at 45 degrees, and let's see what is up and what is down, I guess. Ooh, didn't like that. A little message in here. Missing a bracket? Yep, missing one bracket. I wonder how that happened. Did I add an extra one by accident? I think I did. No, maybe not. Okay, missing a bracket. Okay, there we go. That is 45. So apparently down is up and up is down. It's really slow too. Okay, but that's okay. It's actually moving at 45 pixels per second. Now I just give it a normal speed, like 150 pixels per second. I'm just going to set this to 90 just to make sure. No, that's not the angle. This is no good. 90 should be straight up and down, right? See what 180 does. Let's see. I just want to see. Yeah, it was speed 150, and then angle was 180. Semicolon. Alright, we got a problem with our angle. Let me think about it. Maybe this was a times. There's some right times there. I don't think that's it though. That is definitely not 180. Speed divided by x squared linear times the cosine of. Interesting. Oh, I see what I did here. I did a derp. You see this? I set the angle to the radius back, and it should be A. I think these should still be divides. Okay, that was the mistake. Now we pray. Now we pray. Run it. That looks like 180 to me. Good. 90 should be straight down. So at least we can kind of keep track of our ball now. It has a speed and an angle. I'm happy with that. For now. Okay, so there was the mistake. I probably just got lucky and found that. It would have taken me a long time to find that otherwise. And there we go. So I'm actually going to go back and put it at 45 just for now. It's a good good angle to be bouncing around at for testing stuff, and maybe even a little faster at 250 pixels per second. There we go. So it'll happily bounce around there all day. It's not losing any energy when it bounces because of the restitution and the friction and all that stuff. Okay. And we'll eventually set its radius to something smaller. Let's do it now to 20 pixels maybe. Just a bit of a better ball size for a brick breaker project. Okay. And that's good. Awesome. And actually, it was a lot of borrowing of code. I mean, all of this code was copied and pasted, right? With some very minor changes. And then this line here, which told it to take on all the SFML stuff. So, yeah, that's it. Let's add a paddle really quickly. Same idea. You guys ready? That's all we'll do today is just add the paddle and the ball. And get them interacting tomorrow. And then add some bricks. Good. Get on your way. Okay. So we're happy with that. The way we added the ball was we did file new. So we're going to add a paddle now. Empty file. Do you want to add this to your project? Yep. And I'm going to call this one paddle. .cpp. You're good. Boom. And for the paddle, it's there now, which is good. I guess I'll just copy these 2 lines of code here. So I'm adding physics again in that namespace thing. And I'm just going to make a structure again, struct, and I'll call it paddle. Like that. And when you hit the curly braces, it makes one with a semicolon at the end. Okay. So structures need that semicolon at the end. I wonder if you don't run it, does it give you an error? Yeah, it doesn't like that. It actually gives you a normal error for the first time in C++'s history. Expected a semicolon after the structure definition. Alright, there we go. Wait, for the paddle, do we really need a speed and an angle? No. We're just going to be moving it with our keyboard, so we don't really need that. We do, however, want it to use, so if we write public, we want it to capture all the properties of, I don't even really know if we need to do this at this point. Rectangle shape? I don't think we do, but it doesn't matter. We'll keep it in there anyways. The only variable we'll really need, member variable, is this box2d body thing, b2 body star, and then we'll call it body like that. And yeah, I'm happy with that. We'll have to add our constructor, which launches when we run it. And the constructor, when you call that, it's just the name of your actual structure with some code in there. So we'll put some code in there. We will copy a lot of the code from the box2d file here, the physics file. So here's create box there. Looks like when we create our box, we need to pass it a bunch of stuff, so we'll just copy all of that stuff. And we'll paste it into our paddles constructor function. And the other thing we'll paste in is all of this code. All of it. And we'll edit it as we need. Be there. So paddle's going to be a little easier than the ball for sure, because we don't have speed and angle to worry about right now. I think it would be a good idea to actually not let the person put in a type for the paddle for now. And instead of writing type here, we'll just write kinematic body, B2, kinematic body. Okay. Should be changed. The paddle is a perfect example of a kinematic body in box2d. It's a moving platform, right? Alright, so what do we have to change? We don't have to change any of this stuff. Linear dampening's fine. We've got it's setting its width and height and density, friction, and restitution. It's giving it a shape. It's here that we need to change. Instead of writing this, res, it was creating a box2d body right inside the function. We already have a variable here that's going to keep track of everything for us. We're going to write the word body like that. And then every time we see the word res, we're going to just change it with our variable body, so that later on, if we want to change some box2d stuff, we can just access it all through this word body. And we don't need to return anything. This is not a function that returns anything. Okay, so exactly the same way I did it with the ball, except I did not give it a type. Should just be kinematic body. So if I go and I make a paddle in my project now, it should pop up in auto type and stuff. Making a paddle. And we'll just do paddle. It's auto typing, so that's good. P1 we'll call it. And it's already showing us everything we need for that. That's good. It needs a world. It needs an X and a Y, so I'm going to put it towards the bottom of the screen, maybe at 20 in the X and 550 in the Y. I'll give it a width of 100 pixels and a height of 10 pixels, and that hopefully should add a paddle to the physics world. Just get rid of this mouse drawing all those little boxes there. Let's see if it adds a paddle. No, paddle was not declared in this scope. That's interesting. The thing I forgot to do was include it. Okay, it is a file that exists in my project, but I don't necessarily have to include it. C++ needs me to be very explicit about what I want to include. So hey, look at there, I got a paddle. Let's see if the ball ever hits it. Does it hit it? Yeah, it exists. Cool. So let's add a function, because we didn't do that with the ball. We didn't add any functions to our ball, right? The only function we edited was the constructor, but we didn't add any functionality to it. We're not going to yet today, but with the paddle, we'll add some functionality to get it moving with the keyboard. Okay, so why don't we call this function update position, and it'll be a void function. It doesn't return anything. But we want to call it every time we run our code. Watch. If I just put cout in here and say I'm updating, it's the world's most useless function. But here's how you call it. Okay, you find somewhere in your game loop and you call it every time on your paddle. So you go paddle 1 or P1, sorry, because that's the name of my paddle. And it doesn't auto type, just scaring me a little bit. Update position, there it goes. Look, every frame now he's updating. That function's getting called, so that's cool. So we have a way to kind of update anything we want now. Any code we put in there will run every frame, okay? And we don't have to clutter our main with all of these details. I mean, we could go inside of our main and add code to update the position of our paddle, but why not? Now, this doesn't work for every type of program we're making, but it makes sense to have all the paddle code in one little file, and if something's wrong with the paddle, we know it's going to be in this file. We don't have to go through our main and kind of find code we added that makes it move and stuff. It's all just going to be nicely compact in here, okay? So I'm just going to add some code to move this thing. And that will just be with some keyboard commands, right? If keyboard : is key pressed, is that the one? Yeah. And then you write keyboard : A, sure. If that's pressed, I'm going to set the velocity to I'll set the velocity to my paddle, right? So where's that code that sets velocity? I have it here. It's really messy there. I'm actually just going to steal it from BoxTV again. Physics.h, so get velocity, set velocity. And I'm going to write body in here. And instead of writing all this crap, I'm just going to write like minus, I don't know, 10 seemed fast, right? And if, I'll copy it for the keyboard S as well. S like that. And I'll write plus 2. It's going to be weird. It's going to like keep it moving all the time. Cool. I want D actually, not S. What am I thinking here? Let's run it. There's D, there's A. it moves. Why don't I set it to 0 every time in the up position, so that, oopsie, it only moves if you're actually pressing it, right? So set it to 0, stationary, and we'll give ourselves a little message. Setting paddle velocity or something. Velocity. Yep. Okay. And so I'm gonna run that. Doesn't move, but it moves when I press it now. Isn't that neat? So I've already got a little game here. Boom. We got one minor issue here. You watch. See that? I've added energy into my system by smoking the ball with the paddles. That is one small problem here, which I might just fix right now. The way I'm going to do it is go to ball. Do I want to do it today? Maybe make a ball update position as well. Void update position. Ball might as well have one too. And there's a line of code in physics.h that I added a long time ago. It's called limit velocity. See that? Function that keeps the angle of the block but limits its speed. So you just pass it a speed. So let's copy that line of code. Under ball. And I'm just going to write limit velocity. It's actually going to pull energy out of our project. Velocity. I'll have a video. I'm recording this right now, Aiden, so I'm going to post the video today too. And I'll post my paddle code in a second, okay? But what I changed is this. I changed this to the word body, and this to the word body, and this to the word body, instead of res. I think I changed this too. A little change right there. Changed. Here I'll just write the word body, like that, instead of here. And here I'll write the word body as well. And that should limit the velocity of my ball, as long as I call that update position every frame. And look, it already has the word speed in there, and I have my command as speed, so that's good. So why don't we update the position of our ball every frame to update position. You can see how it's a lot more confusing when you have lots of different files for coding, which is why I always try to avoid it. I think it's kind of good to see it in a brick breaker game, because everything's a little bit more compartmentalized. There we go. It's a little bit weird when it hits the paddle really hard, right? It does weird stuff. It kind of like scoots around it. It's much better than any of the collision detection we made without Box2D in the past. If you ever made like Pong or something with me in grade 11, you could, if you remember, the collision was always a nightmare. Sometimes the ball would get stuck in the paddle and stuff. It's not doing that now. And it is limiting the velocity, which is good. It's not allowing us to add energy to our system. It's actually pulling it away if you smack the ball really hard. Right? See that? So that's good. Tomorrow we'll work on getting the ball to bounce off the paddle at angles. Maybe we'll add a brick as well. Right now it just bounces like law of reflection type stuff. Here I would want it to bounce, yeah, like more like that. How do you think? Okay, so I'll post those videos online.